G'day crew, Ross here, and today I'm in my laundry trying to work out why my dryer is not working. Now dryer is pretty straightforward. It's actually quite simple. So, take away all of this, and what we're looking at is a drum. So we've got a stainless steel drum, and that's where you put all your items, obviously. Somewhere, either down on the left or right, there's a motor, and at the back of the motor, there are some pulleys there, and it's going to have a fan belt, more or less, that goes from the pulley to the back of this drum. Okay, so as the motor turns, that fan belt turns and the drum turns. Pretty straightforward. Now we have a problem that this drum just doesn't turn. So when we're trying to troubleshoot, we need to work out exactly what is working and what is not working. And in a white good, it's generally going to be one of three things. The first thing is there's going to be something with the computer, or something mechanical, or something else electrical. That's pretty much your three items. So the first thing we want to do is turn it on. All right, it's on, and we can see that our control panel here is lit up. Second thing, we're going to try and program it. There you go, 30 minutes. Let's hit the start button. And that is a whole lot of nothing. Okay, now I'm pretty sure I know what the problem is. And it's a similar problem I had with my evaporative air conditioner about a year ago. Where I was told it would cost me $8,000 to fix it, and I fixed it myself for $42. So we'll test that, hey? Now, what I'm going to do, I'm going to move this, and I've got wet towels in here. Towels are heavy, which is why I've put the wet towels in here and nothing else. I want a lot of weight. And you'll notice that I've moved them so that all the towels are up on the right-hand side. Now, these units spin both ways. They'll spin one way for a while, then they'll reverse, and the idea is, things don't get bunched up as much, although they always do anyway. Let's turn that up. So we'll get those towels as high as we can, up on the right-hand side. All right, let's try something. Aha! So that is exactly what it should be doing. Now let me turn it off. Let me try and turn it on again. Nothing. Okay, I think we've diagnosed the issue. So clearly the motor is working. Clearly the fan belt is working. It's not broken because the drum's clearly spinning around. The wheels on there, they're not making any noise, so that's not an issue. And I'm assuming the heater's working fine. What's not happening is it's not able to overcome inertia. And that's really the issue we're dealing with here. Now what happens on these big items like my evaporative air conditioner and also here is you've got a whole lot of weight that needs to get moved. Now once it's moving, your motor, using your 230 volt from your walls, it uses that juice to turn, and the motor can do that no problem. They always start off clockwise and then they'll go the other way, etc. When it needs to reverse, or even just to start up, it needs extra power to overcome inertia. And it can't get the extra power from the wall that's already giving it 230, so it needs that extra juice. And where does it get it from? Well, it gets it from something called a capacitor. Now, a capacitor is a battery, about yay big and about as round as that knob, all right? Well, that's the one in my air conditioner. I'm guessing this one's going to be similar. We'll find out soon enough. That capacitor charges up in a fraction of a second when you first turn this on. So I turn it on, and by the time I even go to spinning this dial, the capacitor's already charged up. All right. Then when I go to start it, and it won't do anything in this case, is that the capacitor discharges its power along with the 230 volt, and that extra juice is enough for the motor to overcome that inertia and get everything going. Now when the capacitor starts to die, it can't do that. So it can't overcome inertia. But when I moved all the towels up to the right-hand side here, we'll try and do this one more time. I'll get them up there. There you go. With the motor trying to do its thing and the weight of the towels pushing down, it was enough, okay? So what that tells me is the capacitor is dying, or there's a problem with the capacitor wiring, okay? Now it's pretty unlikely that the wiring has suddenly died, but it's a possibility. So what we're going to do is I'm going to move this whole unit into the rumpus room next door. I'm going to put it on a big sheet so we can manage all the bits of screws we're going to take out. We're going to take the back off, find that capacitor, take it out, I'm going to take it into my shed, and I'm going to show you how I can test it. Now I know I can do this because I did it with that evaporative air conditioner last year, and in fact I did a video on that. It's a very, very similar process. We're going to do that. Now if we find that capacitor is dead, we'll go and buy a new one. I know it's going to cost $40, $50. Come back and put it in. So let's get stuck into that. I'll move it, and then we'll start taking this thing to bits, and we'll test, see how we go. We're going to start by taking off the back piece, and then we're going to take the screws off all of here, the standard Phillips head screws, and that will allow us to take the sides off, and we'll see what we're looking at then. Now we're going to take off one side of this. And you see here that the screws are different, so don't mix them up. We'll put them in two separate piles. A couple more screws at the top here. I'll just show you this. You see at the top, I've got a couple of screws here and one here holding this front panel on. I should be able to remove those. This will all stay in place, and I should be able to take this side panel off. I'm putting these along the bottom in the order I took them off. 1, 2, 3, 4. 1, 2, 3, 4. Rightio. With any luck, it should pop off. All right, so with the side taken off, here's a few things we can see. Now the first thing, this is the motor, and that's attached to the heat fan at the back. And right here is our capacitor. And it has two wires, red and yellow, and it just attaches via a bolt. So what I'm going to do is I'm going to detach the red one and detach the yellow one. I'm going to go out and get a spanner, undo that. We'll take this out in the shed and we will test it. Simple as that. Right, so here we are in the shed. Now, whenever you're dealing with a capacitor, no matter how small, just be aware these things pack a punch. So you always want to discharge it. Now, the chances are it is discharged, but we're just going to make sure. I've got this is a chisel, you could also use a screwdriver. Make sure you're not touching anything metal. I'm touching the wooden part. I'm just going to put across both of those terminals. There you go. And that'll be fully discharged now. Safe to handle. Right, put that glove away. Now we can see here, what we have is 8 UF plus or minus 5%. That's the measurement of how much this should store, 8 microfarads. Now if we do a test on this and we find that it's less than 8, then we have a problem. So I've got a digital micrometer here, digital multimeter. And what I've done is I've turned it on, and you can see here that I've chosen, right? So I've chosen that one right there. And you notice in the top, it says NF, nanofarads, but this is a self-ranging multimeter. So what that means is it'll find its own range. So it'll start off as NF, and then it will change. Okay, so here's what we're going to do. I'm going to take this, and I'm going to stick the black on one terminal. I'm going to hold it at the back. All right, and I'm going to put the red on the front terminal. Look at the back, 1.71, and I'll do that again, and this time I'm going to zoom right in on the display, and you see that it's nanofarads, okay? But you'll see as soon as I do this, I'll try and do this off to the side, here we go. 1.71 microfarads. Now remember, it's supposed to be 8. So this thing is basically just got to the point where it's not doing its job anymore. It's like a battery that's worn out. It's been charged and discharged too many times. And that is our proof right there. I'll just do it again. 1.7, 1.77 again. And as you can see, it starts with NF right down here. And as soon as I go like that, it goes to UF. And as you can see where my thumb is, 8 UF. At the back, 1.7 UF. So that's the proof that this capacitor is kaput. And what we can do now is we can go buy a new one of these, install it, and I reckon our dryer is going to be fixed. So here we are back in the shed. That is the multimeter setup next to the old capacitor. And this, looking very, very different, is the new capacitor. This is the updated version. Now I went to Mount Barker Appliance Centre at lunchtime. I picked this up for $45, and you can see that it's got 4 terminals instead of 2. However, it is 8 nanofarads. Everything's correct. They've confirmed that it is definitely the updated version of this capacitor. It is the one that they use. Now I'm just going to do a double test again. I've set this to nanofarads, so let's go back and do our test. We'll put that through there, and we will put that there. There we go, 1.768. Yep, kaput. We're going to do the same thing with this one. We're going to test either side of that little white line there. One on the left, one on the right. 8.17, that is our 8 plus or minus 5%. That is now working properly. I'm going to go back and install that now using one terminal on the left, one terminal on the right, and I'm going to turn our machine on and we'll give it a go. Okay, so we'll zoom back in here and I will reinstall this new capacitor. And it comes with a nut and a little spring washer. There we are, just go straight on there. A little anti-rattle washer will go here. Fairly important that you put that on if it comes with one, because these things do rattle around a heck of a lot. There we are. I'm going to tighten it up. Now I've got my two terminals. Remembering, one goes on the left. There we go, and one goes on the right. So now all I need to do is put the side back on, put the top back on, and put it back where it's come from, and our problem is resolved. So here we are back in the laundry and the dryer is where it should be. This is its spot. So we're plugged in, we're turned on, we'll turn the power on. I do know that this button's going to need replacing at some point because it sticks, but that's okay, that's a job for another day. We'll program it, we'll press the magic button and we'll say the magic words. Wingardium, go roundy roundy. Oh, I like it, it's going roundy roundy. Job done, Harry Potter, eat your heart out. Now that's exactly what I wanted. It's exactly what I expected. Now that I've got a new capacitor in there, it's charging, and as this thing's taking off, that capacitor's putting in the extra juice, so it's getting the power from the wall plus the power for the capacitor. Once it goes, the capacitor's done its job, it'll just recharge again, which happens within a fraction of a second, and it's ready for when this thing reverses and goes the other way. So that capacitor will get used multiple times during a cycle as this dryer goes back and forward. All right, guys. Thanks for your time. I appreciate it as always. And until next time, happy fixing. See ya.